Right, everyone. So this video is a little bit different. We're going to do a preview of homework 2. So I'm going to watch you through what to watch for as we get into the course content for this module. This won't prepare you all the way for the exam that will follow, but at least I can direct your attention to certain things here at the start. Homework 2, here we go. You have as much time as you want to get through this. It's open for a week. Question 1, if there is no relationship between x and y, the slope of a regression line will be negative. Well, as we saw in a previous video, if there's no relationship between x and y, I should anticipate a slope equal to 0. So when we start talking about hypothesis tests for whether a slope is statistically significant, the null hypothesis, the default hypothesis, is that there's no relationship between x and y. In other words, the slope of the line will be 0. Look for that in the slides as well, you'll see. Okay? When making comparisons between regression models, the best model is the one with the highest standard error unless multicollinearity is a concern. This is one of those troll questions, all right? You should be able to figure out the answer. Generally speaking, standard error is a measure of the precision of our entire estimation procedure. So a smaller standard error means I have better information, and a larger standard error means I have worse information. And the fact that I just said better and worse should send you in the right direction here. 3. Use this data to answer the next question. Click the data, look at what's going on in each of these tabs, and you'll see different business case stories. Please do not try to answer these questions without looking at the data. Based on the regression results found on the Orders tab, there is a statistically significant relationship at the 95% confidence level between a firm's orders and the month. Here, you'll be looking and trying to make an actual test, a decision. So the hypothesis test is going to be, is there or is there not a relationship between a firm's orders and the month? Statistical decision-making, hypothesis tests require a statement of how confident you are in the conclusion. So 95% confidence level, have a look at the t-statistic, have a look at the p-value, and you'll be able to make a decision. And if you haven't gotten to the point where you understand those concepts yet, go back and review the lecture content for this module. Based on the regression results found on the Orders tab, you have greater than 99.9% confidence that orders are related to the month. I would direct you to something like a p-value for this as well. Based on the regression result found on the Orders tab, more than 10% of the variation in orders can be explained by using month in a regression model. Well, there's one statistic that tells us the proportion of the variance of the dependent variable, y, that is explained by the independent variable, which in this case is x, or perhaps a collection of multiple independent variables. That would be r squared, is what we're looking for. At the 95% level of confidence, or the 0.05 probability of type 1 error, of course a type 1 error is the risk of accidentally rejecting a null hypothesis when the null hypothesis was true. A type 2 error would be the other way around, where you failed to reject a null hypothesis when the hypothesis itself was false. How are orders changing over time? Okay, well, a 95% level of confidence is a 0.05 level of significance, a 5% level of significance. So it's just telling you twice to do this with 95% confidence and test whether the slope is upward, downward, or perhaps no different from 0. Increasing, no change, or decreasing. Based on the regression results found on the Orders tab, conduct a t-test for the null hypothesis that orders increase by $400 per month. Use the 0.05 level of significance. Okay, once again, we're just doing 95% confidence here. So easy, regular level of confidence. We're not treating this as if it's an extreme scenario where we have to be 99 or 99.9% certain that we're not accidentally rejecting the null hypothesis. A t-test for the null hypothesis that orders increase by $400 a month. That's going to be a little bit different from simply testing whether the coefficient is different from 0. You'll need the formula for the t-statistic in order to do this. Also, pay attention to the units because $400 a month may be a specific number in relation to the data that we have on that tab, so be careful there. Question 8, refer to the expenses tab. The plot of units sold versus rainfall exhibits a negative relationship. All right, good luck. You can discern that yourself. Of course, the formal way to answer that question would be to run a regression, perhaps regress rainfall on time, and test whether the slope is statistically significant. It may be obvious from the picture. In some cases, it's not, but we can test it. Refer to the expenses tab. Units sold and expenses are negatively correlated. It's the same question, right? So units sold and expenses are negatively correlated. We'll find out. Refer to the expenses tab. The overall model explains more than half of the variation in units sold. Is R squared greater than 0.5? Then the overall model is statistically insignificant at the 0.05 level. Well, the test for whether the overall model is significant is the F statistic. So look for a p-value corresponding to the F statistic for significance of the overall model. Refer to the expenses tab. Which variables are statistically significant predictors of units sold at the 0.05 level? Interesting. Choose all of them that apply. So we're going to look for p-values on all of these. And notice the intercept is an option here. We can also do a test for whether the intercept is statistically significantly different from zero, meaning we need an intercept. So I've had people ask me whether they should consider the intercept, and yes, of course you can. It's very rare to estimate a regression model and truly believe that it should not have an intercept, but we can treat it the same as the other variables for purposes of discerning whether it's statistically significant. Refer to the expenses tab. If we delete an explanatory variable, the most appropriate choice is interesting. So we're doing a simple version of model selection here. I've got multiple variables that I can include in a regression. If I could delete one, which would I choose and why? Would I choose one that perhaps has very little explanatory power? I think that would be the way to go. And would I choose one that perhaps is not statistically significant? That could be something to look for. It may be that one of them is clearly not helpful in the model output. Refer to the expenses tab. If we could only use one variable to predict units sold, which would have the greatest predictive power? This question is a conundrum, because the previous question says which would you not use, and we may not have the best way of identifying which we should not use. Model selection is actually somewhat challenging, and there are different ways of going about it that can lead to different solutions. But here it says think R squared. R squared has a very interesting relationship with correlation. You may be able to infer the relationship between R squared and correlation using the name R squared. And of course, sometimes we call correlation. So have a thought about that, and have a thought about if you could only use one variable to predict units sold, would you want a variable with a lot of correlation, or would you want a variable with low correlation as far as which will have the most predictive power? Refer to the Rooms tab. The scatter plot contains at least one high leverage case. We're looking for an observation that is far away from the other data in such a manner that it might have a lot of influence on the OLS regression slope. This is essentially the multivariate version of a statistical outlier. Okay? Rooms tab, there is a significant positive relationship at the 0.05 level. Statistically significant positive relationship at the 0.05 level. Because it's specifically specifying positive, you may want to look for if there's any difference in how you would handle a one-sided hypothesis test versus a two-sided hypothesis test. It may well be that the solution is very simple from the p-value if we have a tiny p-value, for instance, but this sounds like a two-sided hypothesis test in particular because it says positive. Refer to the Rooms tab. Which of the following statements is most appropriate? The model is completely useless. That's funny. The current data will generate a stronger fit if we omit an observation. I notice a typo. Or the square root of rope is string. Also funny. Now, this is, in fact, supposed to be a freebie. But I would like you to, if you think that's the only reasonable answer, stare at the data until you can figure out which observation you would omit and convince yourself that you do agree the model will generate a stronger fit if we omit one of the observations. Perhaps there's something like an outlier story in this data example as well. Okay, well, those are all the tips you get from me right now. So good luck studying this. We'll get you more videos very soon, and I will see you in the next one.